Dear risk managers, welcome! Let's say something about the main computational issues of Merton's model. We know that under this model, a default is defined as the event V capital T lower than equal to capital B. The probability is then the one we see on the screen, involving the normal distribution. Under risk neutrality, we can substitute mu capital V with a risk-free rate R, obtaining this new version. This probability depends on many different quantities. Some, like capital B and capital T, are easily known, but for some other variables is not that simple. In particular, V0 and sigma V are two quantities not directly observable on the market. They need to be somehow inferred from data. Regarding R, we can always approximate it with some government bond over a short time horizon. Why is it so difficult to assess V0, the value of the company today? First, from an accounting point of view, the market value can strongly differ from the value as measured by accounting rules. Second, the market value of our company corresponds to the sum of the values of its equity and debt. For equity, if the company is traded on the market, there is no serious problem, but only a relatively small part of debts is really fully transparent and knowable. For example, issued bonds. But what about loans or credit lines? If we assume to just deal with publicly traded companies, the solution can be found as follows. Using stochastic calculus, for the curious one among you, we are using Ito's lemma, we can obtain the relation in equation 1 for what concerns the value of equity in 0. S0 is something that we can observe. The instantaneous volatility of equity, sigma s, can be estimated via the volatility we observe on the market for the shares of the company under consideration. Now, if we combine this new equation with what we know about the European call behavior of equity, we can define two functions, g and f. V0 and sigma v can then be obtained by minimizing the quadratic expression f squared plus g squared, where the only unknown quantities are exactly V0 and sigma v. As usual, with numerical problems, it's always better to have a look at an example. Consider a company whose equity is 3 million euros. The volatility of equity is 0.8. The company's debt is equal to 10 million euros and it must be paid in 1 year. The risk-free rate on the market is 5% per annum. What are the values of V0 and sigma v? What is the probability of default of the company in 1 year? You find the answer on the course platform. Goodbye!